Okay, I wanted to cover really quickly, and it's going to be very quick, some of the situations that I have that are the parts of the circle. Now, in class we did this, but I just wanted to go over it briefly again. So I'm going to start on page 3 of your packet. So, page 3 of your packet just talks about the different parts of the circle. And we're going to just label these. Number 2, number 1, here are the answers to number 1, but let's look at number 2 and see. I have, it says line, because there's arrows on the end, BE. So I have line BE, that is going to be a secant line. Line segment CB is going to be a radius. And you are going to have to know these for the test. Arc AE goes from here to here, and that is a minor arc. And then line AF, so I have line AF, is going to be an internal tangent line. Tangent. And if you have any questions, there are some definitions that we went over in class. This, it looks like, is line segment FG, and line segment FG is a diameter. And then we have angle ECB, and this was the one that was off a little bit, ECB, and that's going to be a central angle. And then line segment AE is going to be a chord. And then I have an arc ABE. Because it uses 3 variables, or 3 points to label this, I know I'm going this way, ABE, and that's going to end up being a major arc. This arc is different than arc AE. Now, if I said arc AE, that would be the minor arc and would be this way around the circle. Point F is going to be a point of tangency. And then line segment BE is going to be a chord. And this is different than the secant that had 2 arrows on the end. And then line JK, it appears that line JK is going to be an external tangent line. Oop. And then I have arc FHG. This is actually a semicircle. And the reason that's a semicircle is because it's equal to 180 degrees, because that is the diameter. And then I have point D is going to be the center. So that's the only thing I think I would add here. So if we said line segment DF, I would add, that would also be, that would be a radius. We do have FG as the diameter. Okay, looking on along over here, I've done this already. But we can go on to the next page. Let's go on to page 5, because it talks a little bit about central angles, inscribed angles, and opposite angles. So central angles are angles that have the vertex in the center of the circle. So the vertex is the center. And this is where, if I know that this angle measure is 139 degrees, this arc measure is congruent to the angle measure, the central angle. So looking on along, like if this right here is 162 degrees, I know that this arc measure is 162 degrees. Now the second definition up here is an inscribed angle. And an inscribed angle, the vertex is actually on the circle. And this is different than the vertex being the center of the circle. An example of this would be number 1 and number 3. So C is my vertex, and it is actually on the circle. And my angle measure is going to equal half of the arc measure. So if my arc is 124, my angle measure is half of that, which would be 62. The opposite also is also true. So if my angle measure is 96, I have to multiply that by 2 to get my arc measure of 192. So, and then the last situation that we talked about is opposite angles. And these are opposite angles of a quadrilateral inscribed in a circle. And this is an example of this is going to be number 8 and number 9. So these are opposite angles here. And this one, you have to do a couple of things, and it tells me that arc RT is 122 degrees. Well, TQR, angle TQR is an inscribed angle, so it's going to be half of that. So the degree is 61. And then I have to subtract 180 minus 61 is equal to 119 to find what x is equal to. Now, number 9 is a little bit easier. These are opposite angles, so I know they are supplementary and add up to be 180 degrees. So 180 minus 34 is 46 degrees. So this covers a little bit about arc measures and how they relate to the different angles that we talked about in class.